Just so you remember, yesterday we started the fundamentals of area and perimeter and looked at the difference. I referred to the perimeter being a fence around your garden and the area being the play area, so where we can play if it's on a grass pitch, for example. And we worked through the basic worksheet. And then near the end of the session yesterday, we jumped into this worksheet, which is exam style questions, where it's bringing in other topics into area and perimeter, because you're very rarely going to get a question in an exam that's based on just working out the area or a perimeter of a shape. Even in level 1, you'll have something added on there. So we've got to question 5. It's my intention today to finish off these questions, breaking down how I'd answer them. And as you can see, they're starting to ramp up in how many marks they're worth: 3, 3, 4, 4, and then a big 6 one to finish off with. So that should take us pretty much through most of the session. If we get a bit of chance at the end of the session, we could look at another topic to start. But what we'll do, we'll start this question here, question 6, because we answered question 5 yesterday with 11 trays. And I do send a blank worksheet out at the end of the session. So if anybody's having a go at them and you want me to mark them, absolutely just save them and send them across to me, and I'm happy to mark them for you and then give you some feedback on where you could have, where your corrections were needed, or if you've got them all right, amazing. And it's a case of, just work together with Atom, with these worksheets, with any other things you can find, NCFE website with the blank exam papers, because we all want as much practice as we can to get used to seeing what's in an exam. So Susie is filling up a rectangular pool with water. Dimensions of the paddling pool can be seen. So I'm not going to draw it to scale because, as you all know, I'm going to draw it better than that though. The pool. Okay, so we've got a pool now that's like that. So it's 2, 1.5, 0.5. She's going to fill it up to half or 50%. So again, relating back to those fraction fundamentals, 50% is half or 0.5. And what this is, so we want 0.5 of 0.5. So we want a half of a half. Or we can work that out by just doing 0.5 times 0.5. So we can see if I split a half in 2, we've got 2 quarters, haven't we? So we want a quarter and a quarter. So this now becomes 0.25. So she's going to fill it up to there. So we kind of draw the water in there. So she's going to fill it up to there. And that now becomes 0.25. So, well, strange. So the volume, to work out, we need 3 dimensions, because remember, volume's with a little 3 at the end. So we've still got 2. Still got 1.5, because those are the layer dimensions, and then layers up we want times by 0.25, and that'll give us the volume. We'll get a calculator out in a second, although we shouldn't really need a calculator, shall we? Yeah, we'll do it in a second, and then we'll have a look at what happens next. So she's going to fill the paddling pool up. Yeah, we've done that. Shall we use a hose pipe that will fill up 0.05 meters cubed of water per minute? Calculate how long it'll take Susie to fill the paddling pool. Okay, so let's get the calculator out now, really, so we need to know the volume. I wasn't sure what it was going to say the second part. So if we worked out the volume, let's put that into the middle, so we can go 2 times 1.5 times by 0.25 equals 0.75. 0.75 meters cubed. And if we think now, it's going to fill up at 0.05 meters cubed per minute. And that's our total volume. So we need our big number. That's how much we want to get the water in. And we're going to divide it by how much water goes in per minute. And when we divide how big our volume is by how much water goes in per minute, it's going to give us here minutes. So total minutes left. Right, so if we do that one, we should still have 0.75 on there. So divided by 0.05, because that's what it says here, equals 15. So it's give us a 15 here. So the answer to fill up her pool to halfway up the depth that she said it is takes 15 minutes. So the 3 marks there, we've got 1 mark for actually recognizing that we're only going halfway up there. So that's your 1 mark. Yep. This is your 2 marks to work out your volume. And then your 3rd mark here is doing what it says here, 0.05 divided into your 0.75 to get your 15 minutes. So there's your 3 marks for that question. If we roll down to question 7, so this is introducing, or not introducing, reintroducing, I should say, circles. We had a question above that was about circles, and I can see circles is coming up next. So when I say that there's only 2 formulas you need to remember with circles, I'll keep saying it, and I'll do it here before we actually get on to question 7. So we've got, it's not called the perimeter of a circle, as it is called a circumference. So let's call it circ, and that is pi times diameter. And when we come to math exams, especially at functional skills level 2, pi is always going to be 3.14. So rather than use your pi button on your calculator, which is to infinite decimal places, use to 3.14 because it will give you a slightly different answer. Okay, so and then we've got the area. So still play area. Think about it like that. Everything in the middle. And that's going to be pi again times by radius squared. Not radius times 2, radius squared. Radius times by itself. And if we don't know what the radius is, it's half diameter. Or if we don't know what the that is 2 times the radius. So when we say radius squared, it's not 2 times the radius. That is what the diameter is, double, because the radius is from anywhere from the outside into the dot in the middle, and the radius is where it's from the outside traveling through the middle to the other side. So you can see it's double. Okay, so let's look at the first question on this circles one here. We've got question 7. The diagram shows a running track that is made up of a rectangle and 2 semicircles. Mo wants to run at least 12 kilometers around the outside of the running track. He can only complete full laps, i.e. he must finish a lap even if it reaches his target of 12 kilometers during the final lap. How many full laps would he need to complete this? So there's a bit of conversion going on here. So if you think about 12 kilometers is meters. So go from kilometers to meters, we times by 1,000. There's 1,000 meters in 1 kilo, meter, kilogram, kilo, 1,000. So for 12 kilometers, that is 12,000 meters. So why am I doing that? Why am I changing it to meters? Well, I can clearly see that all my measurements here are in meters. So if I make my distance, which is quite easy to start with, into meters, it saves me changing this into kilometers, doesn't it? 0.05 or 0.1. It makes it much easier straight away. We've got our measurement in meters for our total distance that we're going to run. And we can see here, we're going to have to run around the edge. So it's the perimeter. And then when we get to the circle, it's a circumference. So we've got 100 meters down that straight and 100 meters up the back straight. So we know the straights are equal to 200 meters. And for the circle, it's 2 semicircles. It says here semicircles. So that's a full circle. We don't need to work out the circumference and divide it by 2 because we've just times it by 2. So we have got a full circle. So we've got the diameter, which is 50, and we times it by pi. And we're not going to divide it by 2, like I said, because we've got 2 half circles, which makes a full. So we'd be only halving it to then double it, which makes no sense whatsoever. So we've got 50 times 3.14, so 157 meters around those curves. So in total, for 1 lap, we've got 350. Oh, I did my 5 the wrong way around. It was 357 meters, 1 lap. So to work out how many laps we need, we've got our big number again. So like we did above, when we had the bath volume, we had the big number, so how far we're going altogether. And we're going to divide it by how far each lap is. Like up above, we divided it by how much water we're filling up the pool every minute. So this is how much meters is each lap, and that's going to give us laps. Oh, it's because I keep my pen on the electric pad for a little bit too long, and it gives me little symbols. So right, we've got 12,000. So let's go 12,000, 1, 2, 3, divided by the total distance around the running track, which is 357, equals 33.61. So if we go 33.61 laps, that gets us to 12,000. Okay, but the question did say here, how many full laps would he need to complete this? And he must finish a lap, even if he reaches the target of 12 kilometers in his final lap. So if we say 33 times 357, we don't get there. Okay, so it's not 33 laps, it's how many full laps. So if we go 34 times 357, we go over, but it says that's what he's got to do. So it's not, your answer's not 33.61, it's how many full laps. So the answer is 34 laps. 34 laps. And that's a 4-point question. So where are you getting 4 points from in there? Well, I'd say you're definitely getting 1 here for converting that into kilometers to meters. So we're getting 1 there. And then we're getting another 1 here for working out. I'd say that bit to start with. Actually, I'd not say that bit. I'd go back around there. I'd say we're getting 1 for working out the distance right around the perimeter of the whole track. And then you get another mark for working out that. And then you get the final mark for rounding it up because you're reading back in the question to see it's in bold full laps. So you're getting your 1, 2, 3, 4 marks for your calculations. That's why it's important. If you're not sure if you've gone wrong in a question, but you feel you're getting the right process, is continue to the end of the question. And if it looks wrong, say you got 496 laps there, and because you pressed something wrong in your calculator, go back and have a look where you might have gone wrong. And quite often in maths, you can see it's common sense along the way. And if you can see where you went wrong in your calculator, then correct it. If you can't see where you got wrong and you still think you got the right process, flag it. And on your exam, you got a little button at the side that can flag it and carry on, because you might suddenly think, oh yeah, that's what I did wrong. I forgot to divide it by 1,000, or I forgot to times it by 100. So you might think, oh yeah, I need to convert it back. We don't on this one because it's not, we converted it right at the very start. But you might get a question where you think, that looks really odd. What's going on? You know, trust your instinct. If you think it looks off, chances are it might be, and come back to it later, but definitely stick with the process. If you've done the process for lots of questions, it's just a case of applying that process to trees, ants, apples, coffee shops. It is always a different story with the exams. It's just a case of applying the same process and kind of ignoring the backstory. The diagram below shows Ian's back garden. He has a patio in the shape of a triangle. Yeah, of course he would. And a pond. Great. The rest of his garden is filled with grass. Ian needs to water each meter squared of grass with 10 litres of water per week. How much water will Ian need to water his grass per week? He could just use the pond, couldn't he? So wouldn't need to do this maths question in real life. We'll just get a bucket out of the pond and get a sprinkler. Right, so let's work out. So we've got to look at the whole area. Okay, so we've got the whole garden. And we're not going to draw it to scale at all here. And then we're going to take off the circle and the patio. Okay, so we'll work out the whole area first. And you can see that if it's a rectangle there, so that one it says it's 12. That one says 20. So the whole of the rectangular garden is 12 times by 20. So remember now, we're not talking perimeter, we're not going around the outside, we're talking everything in the middle. He wants to know what his area of his grass is. So 12 times 20, well, 10 times 12 is 120. So 20 times 12 is 240. Okay, so we know the whole of his grass, the whole of his garden, including his pond and his patio, is 240 meters squared. Okay. Then we've got his patio area, and it's a triangle. So with a triangle, what we do, if I draw it as neat as I can, I'm imagining that to be a rectangle, sorry. And that rectangle is 10 by 5. And once I've got my triangle, I'm going to divide whatever answer I get by 2, because I only want half of my rectangle there. I don't want this bit. I want that bit taken off. So I've got 10 times 5. So we've got 10 times by 5, and we know that's 50. 50 divided by 2 equals 25. So we're going to take off 25 in a minute. Okay, so we need to take off 25. Then we've got this circle part. And if you remember right up at the very first question, we talked about circles. We don't want the circumference now, we want the area. So we want pi times radius squared. Okay, so let's go down here. We want, so for the pond, where it's 5 meters across, we want pi times radius squared. So that's the diameter. So the radius, we need to cut it in half. So we know that it's 2.5. Half of 5 is 2.5. So we've got pi times by 2.5 squared. So on the calculator, what I'm going to do first is my indices. My following BIDMAS, I'll do my 2.5 times my 2.5 first. Okay, that's my indices. So that's bit 6.25. And then I times it by my pi, 3.14. So I've got my pond as an area. That's a big pond, isn't it? Of 19. Oh no, it's gone. 19.625. And we'll keep it as full numbers for now. We don't put rounding them up or rounding them down, because we've got a calculator, we can be quite accurate. So what we've got now is we've got 240 for the whole garden. Take away my garden pond. Take away my patio. And that's going to give us grass equals grass. Okay, so let's do that on here. So we've got 240 minus the patio minus the pond, sorry, 625 equals 195.375. 195.375 meters, and it's squared because it's a flat. We're looking at a map. It's a map, so we only need 2 dimensions, length and width. So we now know we've got grass that covers 195 meters squared and a little bit. Well, that's quite a lot, isn't it? Ian needs to water each meter squared of grass with 10 liters of water a week. So do we say that's 196? Okay, let's say that's 196. Let's go 196. Afternoon. Just literally going through some of these questions. So if it's in the middle of a question, you might think, oh, what's Steve talking about? But don't worry. I've kind of worked out some of the bits for the garden here, and I'm just looking at the last part now where it's 196 meters squared, and he needs 10 liters per week per meter. So we need to times that by 10, because if it's 1 equals 10 liters, we've got 196. So for every one liter we have, it's 10 times bigger. So we've got 196. So it's just times by 10. So we need 1,960 liters of water in 1 week, and that's quite a lot, I think. Yeah. So that's if it wasn't that figure, if we were going to be more accurate, we times that 1 by 10, and that becomes 1,953.75 liters. It doesn't say to 2 decimal places, and it doesn't say to the nearest full meter. So I'm a bit I'm a bit torn on this question. Would I go for the round up here and say that's an extra bit to water? Because we can't round it down because that means we're not watering all the grass. So would I round it up to 196? Probably, and get that question. Quite often in those sort of questions, they give you that if they haven't stipulated if to round up or not, they give you the mark if you had rounded up but done it neatly, which we did at the end, or they'd give you the mark if you didn't round it up and you kept it the full decimal places throughout. And I think there's one more question, which is a big one. So this is the 6-pointer. These are the most this is the most points awarded for any one question on a level 1 or a level 2 exam. So, and this one is looking at, I can see already we've got pi involved, we've got percentages involved. So we've got a whole lot going on here, hence why it's worth 6 points. We're mixing topics, which quite often happens in both level 1 and level 2. On both non-calc and calc, it rarely asks you a straight up 1-point question. In the whole of the exam, you might get 3, you might get a 1-pointer on the non-calc and 2 1-pointers on the calc. You very rarely get lots of little 1-pointers, and that they blend in topics. So you've got to try and link or understand and build the question. So right, Benny has a slush machine that produces a slush drink. The diagram below shows a front view of the slush machine, which is made of a rectangle and a semicircle. The slush machine has a length of 25 centimeters. Okay, so it's in a length. Okay, let's actually draw. It's not very neat. Okay, so that's his slush machine. That bit's 14. Okay, and then that bit's 18 to there. And the length it says is 25, which that means that little bit at the end is 7. And we know that anyway, because half of the diameter is the radius, and then half of 14 is 7. So that kind of gives it away that it's told us the information there, and then that one's that there. Okay, so we've got all the dimensions we need. Let's have a look what else he's saying. Benny's slush machine is filled up to 80% of its capacity. Okay, does it say? Interesting. Benny's machine produces slush drink. The diagram shows below the view of the slush machine, which is made of a rectangular semicircle. Slush machine the length of. Okay, so a minute it's saying area here, isn't it? Interesting. Okay, so let's work out. I'm not sure whether 25, the length, is that going to be that way? So is it saying it's got that? Interesting. Let's have a read what it's asking us to do. Benny's slush machine is filled up to 80% of capacity. Benny sells slush drinks to his customers. Each slush drink contains 300 milliliters of slush. Ben sells these slush drinks for £1.50. Okay, 1 centimeter cubed equals 1 milliliter. How much money will Benny make if he sells as many drinks as possible using all of the slush he has made in the machine? Okay, so I am thinking that it actually, let me just bring my drawing down a bit then, because I've got a feeling it's given us a front, let me try it neatly. I've got a feeling it's given us the front view of his slush machine. And again, an exam, it's not very clear to say it's an exam. That's 14. That's 18. I've got a feeling when it says its length is 25, it means it's going back. That's alter. I think that's what it's meaning. So, oh my word, you get me there. It's like, let me move that line out of the way. So that's going to go back there, and then that's kind of like that. So that line doesn't need to carry on through, but he's going to fill his slush here. So if we worked out, so we're saying that's 25. So this is where it becomes a complicated question, I think, because they've given us all the information we need. However, to understand whether it's what we'd say a cuboid and then half a cylinder, it doesn't say that. It's not very clear. So what we're going to do, we're going to work out what we'd say is the cuboid first. So I'm going to put my line up there, and that'd mean that's why that 18 is really important there, because we've got 25 along. Then we've got the 18, that's the height. And then we've got the 14 along. So we've got our kind of rectangular shape inside, alongside our cuboid, which is the rectangle sort of shape. So let's go 25 times by 18 and times by 14. And if this question, we'll have a look in a minute, but if this question, if I've got it completely, if I've completely gone down the wrong line, then I apologize for confusing people. So that's the rectangle part. Now we need to work out the cuboid part. So let me just get rid of that a minute. So if we imagine that as being a, let me just kind of draw it here. If we imagine that as being a full cuboid. So we've got a full cuboid there. We would cut it in half. So if we work out the full volume of that cuboid, what we need is the area of the circle times by the length, which is 25. So we're going to work out the area of the circle. So to work out an area of a circle, we've got pi times by radius squared. So that's the diameter. So we half that number. So it's pi times by the radius squared. The radius times radius. So 7 times 7 is 49. And then that equals the area of that circle. And then we times it by 25 to get the volume of that cylinder. But then what we must do is half that number because it's not a full cylinder. 3.14 times by 49 equals times by 25. Okay, so that would be the full times 25 equals 3846.5. Then we've got to divide that number by 2 because we only want literally half of that. My drawing, I'm just kind of drawing my own drawing there. Right, we only want half of that. So we're going to divide that number by 2. By 2. That's given us 1,000. So we can see now that that part is 1,923.25. And then we've got, sorry, then we've got to add it onto our rectangle part we had before. Add 6312 equals, so the total volume 8223.25 centimeters cubed. Centimeters cubed. Okay, so that is the total volume of our slush making machine. However, the next part of the question, hence why this is 6 marks. So in an exam, you roughly have 2 minutes per mark. So in theory, we've got 12 minutes to get this question correct. If you get it right in 5 minutes, then yeah, you've bagged yourself some time. If it takes you like 14, 15 minutes, and you think, I've got to try and hurry myself up on some of my stronger topics. So we'll move on and we'll see, right, we need 80% of that number. So if we've got a calculator, we can times it by 80%. But if we don't have a calculator with a percentage point on, it's easy. We change that 80% to as a decimal. And we do that by dividing it by 100. What's going on with my pen today? It seems to sometimes stick and not draw as fast as I'm wanting to write. Okay, so from any percentage to a decimal, we divide it by 100. So now we can do that exact sum here. 0.25 times by our decimal. And that's going to give us 80% of that number times by 0.8. So now we're getting to the kind of part where it's given us the volume of slush we've got. And now we can get to the part where it's asking us about each slush puppy. So let's have a look. We've got, right, Benny sells slush drinks to his customers. Each slush drink contains 300 milliliters of slush. Okay, so we've got, this is centimeters cubed, and it says here for 1 centimeter cubed, it might honestly, the pen today, for 1 centimeter cubed is the same as 1 milliliter. Luna, sorry if you can hear that. Right, I'll carry on, but that's an 11. I think the dog was a bit. Is there some? I think she saw somebody. I think she saw my daughter at the door. Okay, right. We've got 1 centimeter cubes equal 1 milliliter. So we can see here that is basically saying we've got 6,578.6 milliliters. It's exactly the same. Look, it's all it changes is the units. Noisy dog. And we can see that each slush we've got is 300 mils. So I'm going to divide that number by 300 to see how many full cups of slush we can make. So let's have a look. Where's my calculator? Right, so that's our number. We divide it by 300. 1, 2. There we go. So we can make 21.92. So we can't make 0.92 of a slush. We can only make 21 drinks, can't we? We can make 21 drinks. Okay. And we've got 21 drinks we've got here, look. He can sell them for £1.50 each. How much money will he make if he makes if he uses all of his slush? Well, he can't make 0.92 a drink. He can nearly. Somebody might be able to get away with a little bit of a half a drink, but you can't do that. So we've got 21 drinks times by 21 times by £1.50. And sometimes a level 2 question will say about profit, is profits only 50% of what his revenue is. So you'd have to then work out your percentage again, but you don't on this one. So it's saying here he's going to make £31.50. And that will be the answer. I am going to look at the answer for that one because I'm intrigued if it's not if it's not kind of explained in 3-dimensional here, whether or not we'd be expected to know that. So I'm going to actually go out of the questions. I'm going to open up the answers and I'll see what it says. The dog is still grumbling. I don't know why. Right, so let's have a look. Luna, shush. No. Right, so let's scroll down to that one. Okay. There we go, £31.50. So we did have it right. It was just a case, I thought it was quite confusing in the fact that it didn't actually not spell it out, but it didn't actually kind of show you the drinks machine in 3D. It kind of give you a flat picture of the drinks machine. So I was a little bit, for me, I would have preferred it to show the drinks machine in 3D, and then at least you're working with volume. Because for me, that's a flat picture. I'm thinking area, and then it starts talking about here, look, 1 centimeter cubed. Hence why then I started thinking, hang on a minute, it's actually talking about volume. So I need that third dimension. When you read back, it says it's 25. So that's when I changed my picture from, it's a 25 down here. But it is a case of just working back in questions. Right. That is everything from that topic. Is there any other questions or topics you're getting stuck on? So if I stop the recording now, I'll stop the recording. So recording stopped. Is there any other